Okay, so we've got another vector equation question. Relative to the origin we have two lines. Here's one line, here's another line. Do note this is a position on the line or a point on the line, and this is the direction of the line. But do note as well that we don't know this A and this B. Okay, now given that the two lines are perpendicular, find the relationship between A and B. Okay, if the two lines are perpendicular, then their directions dot to 0. So we know from this, we need to know it's the directions we care about, not anything to do with the points on the line. 1, 4 and 5 must dot with 3, A and B to be 0. So let's dot these. It will be 1 times 3, which is 3, 4 times A, which is plus 4A, and 5 times B, which is equal to 0. And that there is the linear relationship we're looking for 2 marks. Now, so I'm going to write that up here. I'm going to write that 3 plus 4A plus 5B must be equal to 0 for part A. Okay, we are also told that the two lines intersect, and it says find the values of A and B for 8 marks here. Now, if they intersect, we can write down the following. The column version of that is going to be 4 plus S, 1 plus 4S, and 1 plus 5S, and I know they're going to be equal to this here if the two lines intersect. So negative 3 plus 3t, 1 plus AT, and negative 6 plus B lots of t. Okay, and so we have got ourselves 3 equations from this. We can get ourselves the following equation, that 4 plus S must be equal to negative 3 plus 3t. That's equation 1. We can also determine that 1 plus 4S must be equal to 1 plus AT, which is equation 2. And we can also determine that 1 plus 5S is going to equal negative 6 plus 6t. Okay, now let's do what we can from equation 1. The only thing we can do from equation 1 is to, let's say, make S the subject. From 1, S would be equal, if I subtract 4 from both sides, it would be equal to 3t subtract 7. And then what I can do is I can sub that into, let's say, equation 2 in here, and I could write that 1 plus 4 times 3t subtract 7 must be 1 plus AT. And I could tidy this up, and I could say that 1 plus 12t subtract 28 must be equal to 1 plus AT. I could subtract 1 off both sides, and then I could, let's say, subtract 80 off both sides and add 28. I could say that 12t subtract 80 must be 28, and I could factorise out the t, and I would have the following is equal to 28. Now I could also sub this into 3. And I would get myself that 1 plus 5 lots of 3t subtract 7 is going to be negative 6 plus 6t. Expanding, 1 plus 15t subtract 35 is going to be negative 6 plus 6t. And I could combine these, so 15t subtract 34 is negative 6 plus 6t. And plus, sorry, it wasn't 60, sorry, I'm making a mistake. These are BT. These are BT. BT, BT, and BT. Okay, and I could add 34 to both sides and subtract BT. So 15t subtract BT is going to be equal to 28. Factorising out the t, I get the following, and I can say that t is 28 over 15 subtract b. Now, both these things, so this here, t was 28 over 12 minus a, just from this one. Now, because both these things are equal to t, they're equal to each other. So 28 over 12 minus a must be 28 over 15 subtract b. And rearranging, the bottoms must be the same if the tops are the same. 12 subtract a must be 15 subtract b. And so add b to both sides. B subtract a must be equal to 3. Now, I have another linear equation with b's and a's in it, which I'm going to call star. And I did in part A that 3 plus 4a plus 5b, so 3 plus 4a plus 5b is equal to 0. So from this one, I can say that b is a plus 3, and I can sub into part A, sub star in A, and I can say that 3 plus 4a plus 5a plus 3 equals 0. 3 plus 4a plus 5a plus 15 equals 0. So I've got 9a plus 15 plus 18 equals 0. So therefore a is negative 2. Subtracting 18 and dividing by 9. And b must therefore be equal to 1. So I found my a and my b at last, but that was a lot of algebra and it was tricky. So I've got my a is negative 2 and b is equal to 1. Okay, and then it says find the coordinates of where they intersect. Well, what can I do from here? Well, I'm going to rub this stuff out here. Well, no, actually what I can do is I can, from that, I know if a is negative 2, I can find t. T must be equal to 28 over 15 subtract negative 2. Sorry, I've got it wrong here. It's b I was substituting in here, my fault, sorry. Over 15, take away 1, so t must be 2. Okay, and there, if a is negative 2, I found here, similarly t is going to be 28 over 12, take away negative 2, which is also 2. So I've got t is 2. Okay, so for part, the last part C, I know that t is equal to 2. Using this equation here, I know that s must be 3 times 2 take away 1, s must be equal to negative 1. And I've got a is negative 2 and b is 1. Now it's just a case of substituting these into these equations here and I get the points of intersection. Okay, so I'm going to sub them into 4 plus s. Actually, let me just take a photo of that. I'm going to take a photo of this here. And I'm going to substitute all of that in and check each of them works. 4 plus s would be 3. 1 plus 4s would be 1 minus 4, which would be negative 3. And 1 plus 5s would be 1 take away 5, which would be negative 4. Let's check it's true on this side. Negative 3 plus 3t. Negative 3 plus 6 would be 3. And then 1 plus at. So 1 plus negative 2 times 2 would be negative 3. And negative 6 plus bt, negative 6 plus 1 lot of 2, it will be negative 4. So the coordinates of intersection are 3, negative 3, and negative 4, and we're done.